This video is also from section 4-2, and it will look at addition rule 2 by working through examples 5 and 6. Example 5. When selecting a card from a deck, what is the probability that the card is a club or a face card? We'll see. I added some light here. We'll see if it makes some of the visual aids a little more potential. That's a little better. All right, so we have a deck of cards. If you're not card players, standard deck of cards has 4 suits, each with 13 cards. Ace through 10, Jack, Queen, and King. So in the definitions of this, a face card is the Jack, the Queen, the King. They have a face on them. So if we want to do this by classical probability, first thing we would do is calculate our sample space. We have 4 suits, 13 cards each. That's 52 cards total. So our sample space is 52. Denominator is 52. And actually, I can pull up here the solution to this, example 5. So denominator is 52. Now, the numerator, we have to start figuring out how many from each suit make it true. If we start out with the clubs, well, all 13 clubs make it true because they're clubs. With the spades, it's just the 3 face cards. With the diamonds, same thing, 3 face diamonds. With the hearts, same thing, 3 face hearts. So 13 plus 3 is 16, another 3 is 19, 3 is 22. So the total probability is 22 over 52. If you like fractions, that's 11 over 26. If you don't like the fractions, 22 divided by 52 goes to 0.423 or 42.3%. Now, the thing to realize with this is addition rule 1 doesn't apply here. The problem, and the reason why addition rule 1 does not apply is the mutually exclusive clause. If we think about the King of clubs and his friends, the Queen and the Jack, they meet both criteria. So the act of pulling a club and the act of pulling a face card are not mutually exclusive. So we can't use addition rule 1. The good news is there is an alternative, and that is addition rule 2. If A and B are not mutually exclusive, then we have this. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of both. All right, so if we look at that in the context of example 5, if we look first at the probability of drawing a club, well, there are 52 cards. 13 of them, and I'm going to accidentally open my equation editor there, but I guess that'll work. 13 of them are clubs. Then if I look at how many face cards do I have in a deck? Well, I've got 3 in each suit, 4 suits. There are 12 face cards. So sample space is 52, 12 of them meet that criteria. But then I need to subtract off the probability that it's both. Again, 52 is the sample space. In this case, there are 3 that are both clubs and face cards. Jack of clubs, Queen of clubs, King of clubs. So 13 plus 12 is 25, minus 3 is 22 over 52. Lowest term is 11 over 26. If you hate fractions, you can take 13 divided by 52 in your calculator, get to 0.25, 12 divided by 52, whatever that is, add that, subtract 3 divided by 52, and you should wind up at the 42.3 that we had seen earlier. 42.3% or 0.423 as a decimal. Now, example 6, very similar. We're going to draw a single card. What's the probability it's a spade or a king? All right, first off by classical probability, which I don't show in the notes or in the examples, apologize. Classical probability, we start by counting. Sample space is 52, because 52 cards. Probability that it's a spade or a king, well, there are 13 spades, plus we have King of diamonds, King of hearts, King of clubs. So altogether there are 16 ways to meet it. So the numerator is 16, denominator is 52. lowest terms, that's 4 over 13. You take 4 divided by 13, or 16 divided by 52, you should get 0.308, or 30.8%. Now, what I show here in the solutions then is the addition rule 2 approach to it. These events are not mutually exclusive, again, because we have at least one thing that meets both criteria, so they're not mutually exclusive. So we want to look at the probability of a spade, which is 13 out of 52. Probability that it's a king, well, 52 cards, 4 of them are kings, minus the probability that it's a king and a spade. That's only 1 out of the 52, so 13 plus 4 is 17, minus 1 is 16, and we wind up the same place.